Very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So once again, I welcome all the class 7th students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7, our ongoing chapter, work, energy and power. And today we are entering into the session number 3. So after the long gap of S7 exams, so we are now entering from second session to third session. So we'll continue where we stopped in the last class. But before that, let us recall what we learned in the last 2 sessions about work and energy. So in that process, first we started discussing about what is work and types of works, right? So first session, when you started the class, we discussed about what is work and what are the different types of works you can see in our day-to-day life. So a simple definition is when a body displaces along the direction of force, then the work is said to be done, which is given by force into displacement. Right? When you come to the types of works, there is a positive work, negative work, and zero work are there. 3 types. We discussed in deep with various examples also. Right? So when your body is moving along the direction of force, then the work is said to be positive. When body is moving against the opposite direction of the force, it is called as negative work. When the force and displacement are at right angle to each other, then the work said to be a zero work. I given so many examples for that also. Then in the second class, we discussed about the energy. So energy is nothing but work only, but ability of work, capacity. How much capacity you have to do the work is called energy. Right? So we discussed about the various types of energies like potential energy, kinetic energy, mechanical energy, electrical energy, nuclear energy, muscular energy. Like there are so many types of energies, heat energy, sound energy. So total energies we can discuss. We discussed about the energies part in the second session, right? So once we recall once again from our materials, what we learned in the last 2 sessions, then we'll go to the third part today, that is about power. Today we discuss about power before completing the chapter. See here, thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, mechanical energy, and many more are there. All these are helpful for us for our survival. Everywhere, some or other place, we'll see these types of energies. Right? Thermal energy is nothing but heat energy. We cannot prepare our food without heat. Of course, fireless is there. We cannot make the water hot without heat. So radiant energy, that is from solar energy, sun energy. We cannot even imagine also. Light energy, chemical energy, nuclear energy. All these are the various types of energy forms. Okay. So remaining part will continue from the material here. When you see in the textbooks, the part of energy here. So energy, types of energies, law of conservation of energy, energy transformation. So in last class, we discussed about almost all the topics. What is energy? What are the types of energies? Law of conservation of energy, energy transformation means how energy is converted from one form to another form. For example, in your vehicle, you put 1 liter of petrol, right? The petrol is a form of heat energy. When petrol burn in a vehicle, it will convert into mechanical energy. Heat energy to mechanical. This is called the transformation. Heat energy to mechanical. For example, when switch on the light and after some time you touch the bulb, you'll feel hotter. Means electrical energy is converting into heat energy as well as light energy also. This conversion from one form of energy to another form is called transformation of energy. Energy neither be created nor destroyed. That is called law of conservation of energy. What happens? It converts from one form to another form. That's all. You convert it, but there is no loss of it. Don't feel that my petrol is wasted. Petrol is not wasting. It is helping you to cover some distance. From the form of heat is converted to mechanical. When you are paying electric bill, don't feel that you are wasted electric bill. You are enjoyed the electricity either by AC or a fan or a bulb or using laptop or projectors. So this is called transformation, where energy can be transformed from one form to another form. Either various different forms to heat also it can convert, or heat also can be converted into another forms. Iron box you take. How you press the iron? Because heat only. Heat only make the cloth to press. How you are getting heat? Because of electricity. When you pass electric current, that electric current is converting into heat energy, with which we are pressing our clothes. That is called transformation. Right? That is transformation of energy from one form to another form. See, energy is here, mechanical energy, potential energy, and kinetic energy, gravitational energy. So the total energy in a system remains constant. It may convert from one form to another form. That's all. There is no loss of heat. Transformations, very important examples you can see here. How one form is converted into another form. See, conversion of mechanical energy into electrical energy. So the potential energy of water stored in the dam change into kinetic energy when fall into height. When the water comes from the height, and this kinetic energy rotates by turbines to produce the electric energy. So from dams they produce electricity. So whenever this water falls from the dams, falling on the turbines, that mechanical energy with which it is coming down is converting to electrical energy by using the turbines. Similarly, conversion of electrical energy into mechanical. So an electric motor, when you are keeping the water up, when you want to pull the water from ground to the tank, what we'll do? We'll use the electric motor. So electric motor, when you switch on the current, electric energy is converted to mechanical. Motor will run. That mechanical energy makes the water to go through the pipe to the tank. What is happening there? Electrical energy is converting into mechanical energy. Conversion of electrical energy into light also. When you switch on the current, light will come. Right? Conversion of electric energy into sound energy. Electric bell. When you switch on the bell, what happens? Sound will come. Why? Electricity is converting into sound by electromagnetic induction process. That we'll learn in the higher classes. Conversion of chemical energy into heat. When the fuels are burned, fuel like petrol, kerosene, okay, chemical energy is converting into heat energy. These all are called as a transformation of energies. So energies can be transferred. There are so many types of energies are there. They can be transferred or convertible from one form to another form to do our work. It doesn't mean that they are wasting, because we neither create the energy nor destroy the energy. It always remains same, but it may change from one form to another form, which is called energy transformation. Right? So this is completely about the energy. Right? So we are done with the work and energy. Both we are done. You work on the worksheets you can complete after going home, or will do in the So before going for this part, that is power, I'll show you one video on energies. After that, we'll come back to the power.
Earthpen. Hello learners, this is Earthpen. Today, we are going to talk about another fun topic in physics. It is all about the types of energy. Energy can be categorized into two broad topics, the kinetic energy and the potential energy. These two are the basic forms of energy, and we know that kinetic energy is the energy of moving objects, while potential energy is energy that is stored. But aside from these two energies, there are also other types of energy. This includes thermal energy, radiant energy, light energy, chemical energy, nuclear energy, electrical energy, gravitational energy, and mechanical energy. Let us discuss them one by one. The first type of energy that we're going to discuss is the thermal energy.
Heat.
Thermal energy, or also called as heat energy, is produced when there is a rise in temperature that causes atoms and molecules to move faster and collide with each other. But how is thermal energy produced? Thermal energy is the energy that comes from the heated up substance, which means that the hotter the substance, the more its particles move, and the higher its thermal energy. To better understand this, let us have an example. Say you have a hot pot. You forgot that the pot is hot, so you grab it with your hand. Now your hand is burnt because of the hot pot. The thermal energy from the hot pot is being transferred to your hand. That is why you felt the burn in your hands. So, better be careful when dealing with hot things. The next type of energy that we're going to discuss is the radiant energy. So what is radiant energy? Radiant energy is a form of electromagnetic energy. This type of energy can take form of visible waves, which is what we call light energy. But we will be talking about light energy later. The sun produces a lot of radiant energy, which is transmitted to Earth as light. Radiant energy that is transmitted by the electromagnetic waves can come in different forms. Some examples of radiant energy are from the sunshine, X-rays, and radiant heating systems. I have mentioned light energy and radiant energy. But what is light energy?
When time is short, you need a pen that can max it for you. When effort soaks the page, only the strongest ink survives.
Light energy is a form of electromagnetic radiation of a wavelength, which can be seen by the human eye. It is a type of kinetic energy. In an electromagnetic spectrum, we can see that light has the wavelength visible to our eyes. Light energy is formed through the movement of photons. Photons are like tiny pockets of energy. So when an object's atoms heat up, photons are produced from the movement of atoms. Also note that the hotter the object, the more photons are produced, and that is how light energy is formed. If you're asking how light energy is used, well, basically, light energy is used to help us see. The light can either come naturally with the use of the sun or fire, but it can also be from man-made objects like candles or light bulbs. Light energy is also used by plants during photosynthesis. Plants capture the light energy from the sun and use it to produce their food. Next, we have the chemical energy. Chemical energy is stored in the bonds that connect atoms with other atoms and molecules with other molecules. Because chemical energy is stored, it is a form of potential energy. So what does that mean? It means that when a chemical reaction takes place, the stored chemical energy is released. Chemical energy is the most widely used type of energy in the world.
So
Most humans don't know that they are already using chemical energy.
Anyway, just we'll continue because we already discussed about them. Right. So that is the various types of energy. Keep seeing. We'll get the innumerable number of energies and informations. We'll see in the next classes. So far we completed out of 3 important words: work, energy, and power. We are done with work. We're done with energies and types of energies and conservation of energy and transformation of energy. Now, the last part of the chapter is power. So commonly we'll use the word power. The power is nothing but the rate of work done. Rate of work done is called power. Rate means how fast you are doing work. How fast you are doing work is called power. Work done by time. How fast you are done. Suppose your work is around for 2 persons. The same work is done by first person in 5 minutes. Second person will take 10 minutes. Then you can say first person is having more power. Means to do the work very fast, the power is more. So power is nothing but the rate of work done. Right? So it is usually said that a machine is more powerful than a man. This means a machine can do more work than a man. A machine can do same work in less time than a man. Thus, power developed depends not only on work done, but also on time taken. So, power is defined as the rate of doing work. Power is equal to work done by time, W by T. Clear? So, work by time is called power. So, all three see work, energy, power, all are connected to each other. But there is a difference in application. First point, power may be also defined as amount of work done in unit time. So power is a scalar quantity, no direction for power. Thus, power depends on 2 factors, the amount of work done and the time taken. So units, when you come, SI unit of power is watt. Watt. The name of the site is James Watt. Work by time, that is joule by second. Work is joule by second or watt by second, or simply watt. Joule by second or watt is the unit. Whereas erg per second is the unit in the CGS system. MKS and CGS. So work done, power is equal to work by time. Work is measured in joule and time is measured in second. Joule by second. Or in CGS system, work is measured in erg and second, erg by second, or commonly known as watt. James Watt, named after a great scientist, James Watt, who invented steam engine based on this power only. Okay? Clear? Now, when you see the practical units, so apart from the watt, there are some practical units are there for the power. So that is electrical power. When you are using electricity, electrical power. So electrical power, in case of electrical power, bulb use is energy consumed by time taken. How much energy you are utilizing in a given time. Based on that only you get the electric bill. So relationship between SI and CGA units. So 1 watt is equal to 10 power 7 erg. 10 power 7 erg per second. So when you come to the practical units of the power, the unit of power in the British engineering system is horsepower. Very important. So 1 horsepower is equal to 746 watt. You see in your vehicle, 2-wheelers also, they'll measure this many horsepowers. Horsepower means how much fast it go, powerful engine, which is nothing but 1 horsepower is nothing but this many watt of power. Very important. See here, 746 watt. 1 horsepower is equal to. So another practical unit of power is, the first one is watt, second one is horsepower, and third one is kilowatt hour. So at home, the consumption of electricity is measured in kilowatt hour. So what is kilowatt hour? 1 kilowatt hour is equal to, kilo means 1000, right? Watt as it is. Hour, because we know that time always measured in seconds only. To measure, convert hours into seconds, we'll get 60 into 60. So 1 hour is equal to 60 minutes. Each minute is equal to 60 seconds. So we'll get 1000 into 60 into 60, 3600. What is there? Second is there. Watt second. So 1000 means we can write 336 into 10 power 3 and 2, 5. 10 power 5. Watt second is nothing but joule. So that is given relation. Conversion is given here. 1 kilowatt hour is equal to 36 into 10 power 5 or 33.6 into 10 power 6. Is mentioned clearly. So 36 10 power 5 also equal to 3.6 into 10 power 6 joule. So this is the unit of electric power. Unit of electric power. So that is what is kilowatt hour is nothing but 1 unit. You can call 1 unit na. When you consume 1 unit of electricity, you will get some bill every month. How many units are you consumed into some rupees? You will get the bill. So that see, if you go and see at home, you can find electric meter. See over that it will have kWh. What is kWh? 1 unit, common word. How many kWh you are utilizing? Based on that much bill will come for us. So that is a practical unit of or electrical unit of power. So power can be measured in directly in watt or horsepower, where 1 horsepower is equal to 746 watt. Also measured in kilowatt hour, which is equal to 3.6 into 10 power 6 joule. There is a lot of conversions are there. We can convert joules into erg or joules into watt, watt into joule or into horsepower or into kilowatt hour. As per our requirement, wherever what we have to use, we can use the unit in a various fields. Clear? So this is about the power. It's small topic about the power. So far we are done with all the 3 parts of the chapter: work, power and energy. Right? So some more last part, power in terms of force and velocity. Another way also you can define the power. Power can be also defined as product of force into velocity. Power is equal to force into velocity. Also you can define. So how you got see here. So as you know, power is equal to work by time. Work is nothing but force into displacement by time. Work is force in displacement by time. Displacement by time is nothing but velocity. So you know velocity is equal to distance by time. Sorry. Right? Just a minute. Oh, disconnected. Right, okay, just a minute. I'll connect you. There is some technical issue. Right. So you can see here clearly the last part of the chapter, power in terms of force. So power, we know power is equal to work by time. What is work? Work is nothing but force into displacement by time. But what is displacement by time is nothing but velocity. So you can write power is equal to force into velocity also as per requirement. Displacement, distance by time is nothing but velocity only. Speed or velocity. So in this part, so power can be either work by time or force by time. So force is measured in Newton. Velocity is meter per second. So Newton meter per second is a unit here. Right? So distinction between energy and power. The energy is the object tells the total amount of work done. It can perform without any reference to the time in which the work done performed. Power is on the other hand, it is the rate at which the work is done. For example, I'll tell. Simple example. When you are study hours or E&D classes, some target is given for you, 5 questions. Some of students may complete 5 questions. For everybody is given 40 minutes only. Some can complete the 40 questions in 30 minutes only. Some may complete 35 minutes, some may not complete. They'll take more time, 1 hour. They are having energy, they can complete, but they need more time. But those who done that work in given time or less than given time, they have more power. Even though you have more energy, you may not have more power. That is the difference between the energy and power. Okay. So I think that's all. Nothing more about this chapter. Next, we are going to start a new chapter when we meet next time. That is about pressure. Right. So various types of energies we have seen. What is work done? Types of work done. Energies. Types of energies we have seen. And now in terms of power, what are the units of power? Conversions of various units like electrical energy and all electric power, and how power is in terms of force and velocity. What is the difference between energy and power? Right. Clear about? So with this, we have done with the 4th chapter. We have completed the 4 chapters. And when we meet in the next class on Friday, we are going to start our 5th chapter, pressure. Pressure is a very small chapter. After that, we have one more chapter, heat, then followed by light and electricity. So maximum, we can finish up this syllabus by end of the Jan or December end, we'll try to complete. So, right. So that's all for today after the work energy power chapter. So that's all. Thank you all of you. Have a wonderful day. Thank you.